3, 2, 1.
Hi guys, so today what we're going to do is I'm going to teach you in a video. You're going to watch the video and follow along in your packets that you will be receiving. So your packet's going to look like what you see on my screen here. Basically, we need to spend this class period reviewing what goes into writing a high-level experimental protocol. So that's going to include writing procedures, putting together data tables, and putting together graphs. What does that look like? What do you need to include, et cetera, et cetera. So how this is going to work is as you go through the packet, I'm going to explain to you what you're seeing. You're going to respond to anything that's highlighted in yellow. When you're responding to questions, just pause the video, respond to the question, and then once you've responded, press play and you can continue the video. So today what you're going to be doing is you're going to create a procedure and organize data for an experiment to find the melting point of wax. So imagine you have a candle, you light the candle, and you want to know at what temperature does the candle need to get to before the wax starts to melt. So that's kind of the experiment that you're focusing on today, and you're going to use this experiment to review what should a high-level data table look like, what should a graph look like, and what should a procedure look like. So before we continue, what I want you to do is I want you to stop the video, respond to questions 1, 2, and 3. So these are just introduction review questions that are going to prepare you for the rest of today's lesson. So press pause. Once you've responded to questions 1, 2, and 3, press play again, and we'll continue. Great, so hopefully you were able to respond to those questions quickly and easily. What phase change are we looking at today was actually in your objective. We're looking at melting, what states of matter. You're going from a solid form of wax into a liquid form of wax. And then what is a melting point? This is an important point here. A melting point is going to be a temperature. So anytime you see melting point, boiling point, et cetera, you're actually describing a temperature that something has to reach before it begins to melt. So what is a boiling point? A boiling point is a temperature that the wax in this example has to reach before it begins to go through a phase change. All right, so we're going to move on to part number 1. So today's experimental question is, what is the melting point of wax? So imagine you've set up this experiment. You want to know what temperature does the candle have to reach before it begins to melt. So what I want you to do is I want you to pause the video and actually respond to question number 4. So I want you to hypothesize what you think the melting point of wax is. Just make a prediction, but make sure your prediction has units, either Celsius or Fahrenheit. I don't care. You just need to have a number there followed by units. Pause the video. When you're done, press play and we can continue. Great, so now we're going to spend some time reviewing experimental variables for today's experiment. The variables are kind of hard to establish, but I just want us to get a sense of what are experimental variables, review them very quickly, and then you can respond to the questions that follow. So experimental variables, if you want to record this in your notebooks, I think that that's going to be absolutely helpful since you don't have textbooks to reference. If you record this in your notebook, you'll have your notebook to reference when you're studying for your assessment. So you have your independent variable. This is going to be a variable that is intentionally changed by the scientist. You have your dependent variable. That's the variable that changes in response to an independent variable, and these are going to be measurable changes. So if you look at my example below, I said that drinking Red Bull will increase your performance on an assessment. So if you look at that experiment, we would say that our independent variable is Red Bull consumption. Whether you drink it or you don't drink it, it's going to have an effect on how you perform on the assessment. And so then your dependent variable is going to be your performance on the assessment. So if you drink the Red Bull, you should be seeing higher test results. If you do not drink Red Bull, this experiment's assuming that you may not have as good testing results. Controls are going to be things that remain the same throughout the entire experiment. So looking at our Red Bull experiment, you'd want to make sure that if you're looking at someone, you're looking at a group of people drinking Red Bull and a group of people not drinking Red Bull. The group of people drinking the Red Bull should be drinking the same kind. They should be drinking the same amount, so the same size cans of Red Bull. And you'd want to make sure that all students are taking the same assessments. You wouldn't want some taking an ELA assessment while others are taking a math. You'd want it to be the same and controlled across the board. So if you want to pause the video now, you want to start to think about going back to our investigation today, you're going to be applying heat over time to wax in order to observe the phase change melting. So what you need to do is you need to pause the video and actually define the experimental variables for today's investigation, those being your independent, dependent, and your controls. So pause the video. Once you think you've responded to this question enough, you can press play and we'll continue. Great, so for today's experiment, as I said, defining the variables is a little tricky. It's a little bit different than general experiments that we've looked at before. So for today's experiment, imagine that you've set up a hot plate and you have your wax, and you're going to apply heat to the wax, and you're going to measure how does the temperature change and at what temperature does the wax finally begin to melt. So actually what you're doing is your independent variable is time, right? Because you're applying heat over time. You're not changing the amount of heat, like you're not changing the amount of heat that you're applying on the hot plate. So the thing that's changing throughout the experiment that you as the scientist are changing is the amount of time. So that's your independent variable. As you apply heat over time, what's going to happen is you're going to see that the temperature of the wax changes. So that's your dependent variable. And then finally, some controls for today's experiment could be, one of the controls is the amount of heat that you're applying on the hot plate. You want it to be at one consistent temperature for the entire experiment. The other control could be the type of wax that you're looking at. If you're doing various experiments, you want to make sure that you're using the same wax across the board. You also want to make sure you're using the same amount of wax across the board, et cetera, et cetera. Great, so if your variables did not match what I just reviewed, you need to take some time, you need to pause the video, and you need to correct your variables so that they reflect what we just discussed should be today's variables for this investigation. All right, so now we're going to look at part 3, which is writing experimental protocols. As I said before, you may want to record what should be included when writing experimental protocols in your science notebooks. So as it says that for experimental protocols, you must include steps that move in a consecutive order. So that means that step 1 is going to be this, step 2 is going to be this, step 3 is going to be this. You need to have steps when writing an experimental protocol. You must be specific, meaning that you're including a description of all materials being used. So if you're using hot plates, if you're using beakers, if you're using thermometers, those need to be referenced when writing your protocols. And then finally, you need to make sure that your experimental protocols are concise and not too wordy. Once you've recorded that information in your science notebooks, you need to pause and you need to respond to question number 8, which is how will you find the melting point of wax using the materials listed below? You need to write an you need to write a procedure for today's investigation in the space provided below, and you need to consider that you're only collecting data for 10 minutes. So your materials are going to be a beaker, a hot plate, a test tube with candle wax, a ring stand with a clamp, water, and a thermometer. And if you move down, I actually provided you a picture of what this experimental setup should look like. So you have your beaker filled with water, you have your test tube here that's being held by the clamp, and then in your test tube you can actually see some wax, and then within the test tube itself I've added my thermometer, and then this is all being held with a ring stand here. So you need to describe how you would set up your experiment so that it looks like this above here. And then what's not included in this picture is how you're going to record your data, for how long are you recording your data, at what temperature are you going to set your hot plate, et cetera, et cetera. So you need to include those details when writing your procedure for question number 8. So pause the video, respond to question 8, and when you're ready to move on, press play. Great, so now we're going to move on to part 4, which is data tables. As mentioned before, you should record the following in your notebooks so that you have this to reference later. So all data tables that you are asked to put together on any assessment need to include the following. You must have a descriptive title. This is something that I didn't see a lot in your study guides. Some of you had titles, but they just were not descriptive, or some of you did not include titles at all. All right, so in addition to a descriptive title, you need to make sure that your rows and columns have labels. When you're labeling them, you need to make sure that units are used to measure the whatever you're measuring in your experiment. So if it's time, you need to make sure that you tell me how you're measuring time, minutes or hours. etc. And you need to make sure you have space to record data.